So, hello everyone, welcome to the very first session of ABS chemistry classes. In this session, we are going to discuss, understand and learn atomic structure. This is a very important chapter for both NEET and JEE aspirants, as every year around 2, 3 or even 4 questions arises from this chapter in the paper. So for us it is very important to understand all the small aspects of this chapter very clearly. At the end of the session, we will discuss all the important questions regarding the topics of that session. Also, at the end of the chapter, we will discuss extensively all the questions regarding this chapter. So, let's start today's session. So, the term atom came from a Greek word, atomos, that means uncuttable. In India, atom was known as paramanu. Many ancient philosophers gave many philosophical ideas, explanation of atoms, but the problem was they were unable to give any general experimental framework about the particle. The first scientifically acceptable explanation of atom was given by Sir John Dalton in 1803. So let's explain the postulates of Dalton's atomic theory. The first postulate was every element consists some smallest particle that possesses all the physical and chemical properties of the element. Also, the atoms are of two types. One is simple atom that mainly forms the elements, and compound atoms that forms the compounds. Number one, atoms are smallest particle. Atoms are smallest particles and are of two types, a simple atom and b compound atom. This postulate of Dalton's atomic theory was proven to be wrong, as in later days many particles, smaller particles like electrons, protons, neutrons were discovered. Also, there is no existence of compound atom. There are compound molecules but not compound atoms. Also, atoms doesn't show the physical properties of an element. Physical properties of the elements are shown by molecules, but these all concepts were not known at that time. The second postulate was atoms are unbreakable by any physical or chemical means. So, number 2, atoms are unbreakable by any physical or chemical process. But with the discovery of nuclear fission reaction, it was known that some large radioactive unstable atoms can be broken into some smaller stable nuclei in nuclear fission reaction. So this postulate was also proven to be wrong. The third postulate was atoms are rigid. Number 3, atoms are rigid. But today it is known that about 99% space in an atom is void. So atom is not rigid. The fourth postulate was atom of a single element are identical in all physical and chemical means. Atom of a single element are identical. But with the discovery of isotopes, this postulate was also proven to be wrong, as we know for isotopes. For example, if we took carbon 13 and carbon 14, two isotopes, then we can see that their mass numbers are different. So their atomic weight will also be different. So they will be different in their physical appearance, although they are the atoms of a same carbon element. The fifth postulate was atoms of two different elements are different by all means. That means if we take two atoms of two different elements, then they will be different in all physical and chemical behavior. But this was also proven to be wrong with the discovery of isobars. As per isobars, we know that the atomic numbers are different but the mass numbers are same. As for example, if we take nitrogen 14 and carbon 14 as example, so we can see that their mass numbers are same, so their atomic masses will also be same, so their physical appearance, that is mass, will be same, but they are the atoms of two different elements, so this postulate was also proven to be wrong. The last postulate was, during a chemical reaction, simple atoms will combine in a simple whole number ratio to form compound atoms. Simple atoms combine in a simple whole number ratio to form compound atoms. This postulate was also proven to be wrong, as in glucose, that is C6H12O6, the ratio of carbon, hydrogen and oxygen is 6:12:6. So the ratio of carbon, hydrogen and oxygen is not a simple whole number ratio, it is a compound ratio. Also, in case of sodium chloride, the Na 0.72 Cl, the ratio of sodium is to chlorine is 0.72 is to chlorine, which is not a 0.72 is to 1, which is not a whole number ratio. Although all the postulates of Dalton's atomic theory was proven to be wrong, it has immense importance scientifically because it was the gateway for the research of atom. Also, at that time, when the theory was put forward, all these facts were not known, so people widely accepted this theory as true, and the acceptance was there for about 100 years. The first experimental contradiction with Dalton's atomic model arises with the discovery of electron. So our next topic will be discovery of electron. The discovery of electron was not a single day event. It took about 40 years of long research to discover electron specifically. The first observation was made in 1859 by H. Geissler and J. Plucker in Germany. So what they observed? They observed that when in a gas discharge tube at a low gas pressure, high voltage was applied, a glow of light around the cathode. So let's first understand what is a gas discharge tube. Gas discharge tube is nothing but a hollow glass tube in which two metal strips are incorporated, which are attached to a high voltage supply. A vacuum pump was attached to this tube to remove all the gases from this tube to make the pressure inside this tube very low. So in their setup, the pressure inside the tube was 1 millimeter of mercury column, and the potential difference between two electrodes were 350 volt per centimeter. So you can understand that potential was very high. If the tube was 10 centimeter long, then the potential difference will be 3500 volts. So with this setup, they observed a glow of light around this cathode. So this is the cathode. This is the anode. Okay. In 1876, E. Goldstein named this radiation as cathode ray. By E. Goldstein, as the glow was appeared around the cathode. The major characterization of this cathode ray was made by William Crookes and J.J. Thomson. And J.J. Thomson is also known as the discoverer of the electron. Let's see what were their observations and what were their setup. In William Crookes and J.J. Thomson's setup, everything was same about this, just the pressure inside this tube was 0.01 millimeter mercury column. So with this setup, they observed that a radiation was traveling from cathode to anode. This radiation travels in straight line. This radiation also travels in straight line. How did they observe that? They put an opaque material in the direction of this radiation and they observed the shadow behind that substance. So that was only possible if the radiation was passing through the straight line. They also observed that the radiation deflects when it was put in an electric or magnetic field. In electric field, the radiation was attracted towards the positive plate of the electric field. So they concluded that the radiation was actually a stream of some small particles that has some negative charge. Also, they observed that the radiation was deflected in magnetic field according to Fleming's left-hand principle. The next observation was the stream which was constructed by the particle had some momentum. When they put a paddle wheel in the path of that radiation, the paddle wheel started rotating. So the particle that consisted the radiation must had some momentum which was transferred from the particle to this paddle wheel and helped the paddle wheel to rotate. They also observed that when this radiation falls on some metal plate, X-ray was emitted. So that radiation also able to produce X-ray. When this radiation falls on some fluorescent material like zinc sulfide or barium platinocyanide, so let's understand fluorescent material. Fluorescent materials are the materials that glows when some high energy particles falls on it. That is the fluorescent materials. So this radiation was able to produce fluorescence upon falling on a fluorescent material. Also, this radiation can affect the photographic plate and can produce ionization in gas. So that was all the observations of them. Later, the final conclusive experiment was done by J.J. Thomson. That was J.J. Thomson calculated the charge to mass ratio of electron, and currently he is known as the discoverer of electron. So with the discovery of electron, it was pretty obvious that inside an atom there must be some positively charged particle, as atom was as a whole neutral and electrons were negatively charged. So let's see how the positively charged particle, which is currently known as proton, was discovered. Discovery of proton. The first observation in this regard was made by E. Goldstein in 1886. E. Goldstein in his setup used a gas discharge tube with perforated cathode, and inside the discharge tube the gas taken was hydrogen at a pressure of 0.01 mm of mercury column. So let's see his setup. So in his experimental setup, E. Goldstein used a gas discharge tube with perforated cathode electrode. Inside the tube, the gas was hydrogen at 0.01 mm of mercury column. So with this setup, he observed that along with the cathode ray, a new radiation was observed to travel towards the cathode and traveled through the perforations of the cathode and heated the wall of the gas discharge tube. As the new radiation was traveling through the perforations of the cathode, Goldstein named this new radiation as canal ray. Canal ray. Later in 1898, W. Wayne made some remarkable observations about this ray. His first observation was, just like the cathode ray, this new radiation was also traveling in straight line. So this radiation also travels in straight line. His second observation was, this new radiation also deflects in electric and magnetic field, but the deflection was towards the cathode. So it was pretty obvious the ray consisted some particle which had some positive charge, and later it was also seen that the particle that consisted the radiation had some momentum. So second observation was, in electric and magnetic field, this radiation deflects. Third observation was, the radiation consists some positively charged particle, positively charged particle which had some momentum, The fourth observation was, the characteristics of this radiation was dependent on the gas used inside this tube. Character of this radiation was dependent upon the gas inside the gas
inside the discharge tube. So these were the observations of W. about this new radiation, and he named this radiation as anode ray as it was traveling from anode towards the cathode. So this was termed as anode ray. Then he calculated the charge to mass ratio of the particle consisting the radiation, and also observed that it is highest for the particle which was generated when hydrogen gas was used. So Q by M ratio is highest for hydrogen gas. Later in 1919, E. Rutherford characterized this particle as a fundamental particle with his experiment, and also he explained how the radiation was generated inside this discharge tube. So let's see what was Rutherford's experiment. In his experiment, Rutherford bombarded nitrogen atom with high energy alpha particles and observed that a new nuclei was generated which was nothing but heavy oxygen nuclei, along with a new positively charged particle was ejecting. The ejected positively charged particle had mass and charge similar to that of an hydrogen ion. So he bombarded nitrogen with alpha particle, that is a helium nuclei, and observed that an oxygen nuclei was generated along with a positively charged particle which had charge and mass similar to that of an hydrogen. Before conducting this experiment, Rutherford had given his atomic model. So it was known to him that all the positively charged particles were centered in an atom at a particular point, and electrons were revolving around that particle. A positively charged particle was ejecting from the atom. That means that must have been ejected from the nucleus of an atom. So he concluded that every nucleus of an atom was consisted of hydrogen nuclei or hydrogen ion, and later he termed this fundamental particle as proton. So this was termed as proton. Later he explained the cause of generation of this radiation inside a discharge tube. So the cause was when high potential difference was applied between these two electrodes. Electrons with high energy was traveling from cathode to anode. So these were the stream of high energy electrons. So these electrons were hitting the gas molecules present inside this discharge tube. So when this electron with high energy was hitting a gas molecule, the gas molecule was ionized, and these ionized gas molecules were attracted towards this cathode, which was seen as the radiation in this tube. So this was the cause of generation of this anode ray inside the discharge tube. So that was all for the discovery of proton.
So we have seen that electrons were discovered in 1897 and protons were found in 1886. So all electrons and protons, that is positively charged particles and negatively charged particles, were discovered in an atom. So it was the main question how they were inside an atom. So to explain the position of electron and proton inside an atom, many atomic models were put forward. So can you say who gave the first atomic model? If you can, then do write it in the comment box. J.J. Thomson discovered electron, and he also understood that there was some positively charged particle in an atom. So the first model which was put forward was by J.J. Thomson. In his model, J.J. Thomson described atom as a positively charged sphere in which negatively charged electrons are embedded in such a way that the repulsion between electron and proton were counterbalanced by attraction between electrons and protons. So in his model, J. Thomson considered atom as positively charged spheres. And negatively charged electrons were embedded in it. This was known as Thomson's plum pudding model. Thomson's plum pudding model, also known as Thomson's watermelon model. Later, it was observed that this model was unable to explain many theories of electromagnetism. Also, this model was unable to explain the atomic spectra. What is atomic spectra? We will see that in next session. And finally, with the Rutherford's experiment, this model becomes completely invalid. Before going to the next topic, if you find this video useful, then do press the like button, also the subscribe button along with the bell icon, so that you never miss any of my videos. And if you have any queries regarding any topic, and then you can DM me in Instagram. My Instagram ID is ani1.127, which is flashing right below. So now let's see what was Rutherford's alpha particle scattering experiment. Rutherford, Geiger and Marsden conducted the following experiment. They took a gold foil of 0.0004 millimeter thickness, a source of alpha particle and a lead box, and the setup was like this. So this was the gold foil of 0.0004 millimeter thickness. Barium 83-214 as the source of alpha particle, which was put in a lead box with a pinhole, so that one can get a narrow stream of alpha particle, and the whole setup was covered with a glass screen coated with fluorescent material zinc sulfide. So glass screen coated with zinc sulfide. This is the lead box, and this is the source of alpha particle. So they observed that the most of the alpha particles were passing the gold foil undeflected. Few alpha particles were deflecting by a very small angle. and very few alpha particles were deflecting by an angle more than 90 degree. As you know from your previous study that alpha particle is nothing but a helium nucleus, that is a dipositive helium atom. So this is a pretty large particle. So something is deflecting this large particle must have some large mass, also must have some positive charge so that it can deflect this large positively charged particle. So from these observations, Rutherford concluded that all the positive charge and all the mass of an atom is centered at a particular point, and that point was termed as nucleus. Most of the spaces inside an atom was void, was vacant. That is why alpha particles were passing through the gold atoms undeflected. Based on these results, he calculated the size of an atom and also the size of a nucleus and found that a nucleus is about 10 to the power 5 times smaller than an atom. So we can consider a nucleus as a tennis ball. If nucleus is a tennis ball, then the atom will be a field, okay, with a field of radius about 5 kilometers. So you can understand how big it is and how small the nucleus is with respect to the whole atom. Based on these observations, Rutherford put forward his atom was in Rutherford's atomic model. In his atomic model, Rutherford considered that all the positive charges and the masses of an atom are centered at a particular point, and that is termed as nucleus. And the electrons were revolving around this nucleus following some certain circular path that was known as orbits. He explained the stability of an atom in the following manner. If the electron was revolving around this nucleus, then with a velocity of v, then the centripetal force of the electron will be centripetal force will be mv square by r square, where r is the distance from nucleus to electron. And the Coulombic attraction force between this nucleus and the electron is Coulombic attraction is equal to Ze into E divided by R, where Z is the number of protons present in the nucleus, so equal to Ze square by R. So this atom will be stabilized only when these two forces are equal, that is mv square by r square is equal to Z square by r. This was the this was the condition of stability of Rutherford's atomic model. In later days, many major drawbacks of this model was found. So let's see what are the drawbacks of Rutherford's atomic model. According to Maxwell's theory of electrodynamics, any particle, any charged particle, if revolves around another charged particle, then the revolving particle continuously emits energy. So its energy gets lowered. So with this consideration, if electrons were revolving around this proton, electrons would emit energy continuously. So with the energy of electron will be lowered, so velocity will also be lowered, and the attraction, Coulombic attraction between electron and proton is constant as charges are constant. So electron will fall on the nucleus following a spiral path if Rutherford's model was true. So the Rutherford's model cannot explain the stability of an atom by only considering the centripetal force and Coulombic attraction force. The second drawback was the actual spectra of an atom is line spectra or discontinuous spectrum. So if we put absorbance versus wavelength lambda, then actual spectra will be this manner, that is discontinuous. So see, there is a null point, there is a null point as well also, or we can represent it like this: absorbance versus lambda. So this is the discontinuous spectra, this is the actual spectra of an atom. Actual spectra. So as we can see, if Rutherford's model was true, then electron will continuously emit energy. So the spectral representation should be continuous. Spectra should be continuous if this model was true. So absorbance versus lambda should be continuous. So Rutherford's model also cannot explain the discontinuous spectra of an atom. So that's all for today. In the next session, we will discuss about what is spectra in detail and also some advanced atomic models. Before closing today's session, let's summarize today's lesson. Today we have studied how the concept of atom was developed. Then we've studied how the subatomic particles like electrons and protons were discovered. Also, we have studied two basic atomic models. One is J.J. Thomson's plum pudding model and Rutherford's atomic model. Let's see what are the important questions regarding today's topics. So, the first question is, who calculated charge of an electron? The options are J.J. Thomson, R.A. Mulliken, E. Rutherford and J. Plucker. Let me read one more time. Who calculated charge of an electron? The options are J.J. Thomson, R.A. Mulliken, E. Rutherford or J. Plucker. The correct option is R.A. Mulliken. The second question is, what were the constituents of the anode ray? Options are proton, electron, neutron or positive ions. Most of you will mark the answer as proton, but actual answer is positive ions. Okay, last question is, who discovered nucleus in an atom? Who discovered nucleus in an atom? Options are E. Rutherford, J.J. Thomson, R.A. Mulliken or Niels Bohr. The correct option is E. Rutherford. So that's all for today's session. Let's see you another new session. Till then, stay home, stay safe and always put your mask on while going outside.